how we can optimize power consumption on the service provider core network. Before we think about optimization and automation of a service provider core network, we need to answer a few questions. First, is it feasible to optimize the network? And secondly, is it worth it? We need to quantify the operation. My name is Guillaume, and today I will guide you through a use case study we have been pursuing with a service provider in Europe around a journey on optimizing their power consumption of their core network using an integration of a capacity planning tool, WAE, WAN Automation Engine, and our beloved Network Services Orchestrator, NSO. I'm part of a service provider innovation team for Cisco. We've been engaging with our customer in their innovation project for the past years. We started with automation, observability, and most recently, we've been dealing with the top one priority, or most of the priority service provider are driving is now, we have energy management in our network operation to deal with. How can we handle that? So obviously, it's a long journey, right, with a lot of step-by-step approach. But in that journey, we can leverage some common set of tooling that will help us bringing to some optimization. So we start with a common ground, a common platform of several tooling that you can use it. It's a kind of a toolkit that you can use it to optimize your network. You might already be using some capacity planning and design-based tooling. You might already be using open source or domain-specific vendor observability platform to get data from your network. And I guess, because you're here, you're using some automation platform to interact with your network. But the source of truth is the network, right? So if we want to be able to build use cases for energy optimization, we need to get those platforms, those tooling, energy aware. That's why we try to build on top of this platform some energy insight extensions to get really power and awareness to those platforms. And only then we can think about building some relevant use cases. So some of the use cases that we've been displayed earlier were more around observability and getting some ideas on what was my most consuming services or what were my most consuming devices in my network. So in a sense, we try to highlight maybe the outliers that we could have on the network. And for the topic of today, I'm more interested in to say, can we try to create a decisional making platform that will help you drive the automation of your network by, for example, doing some quantification, like we need to do the value of such optimization. And most importantly for me, the feasibility of such operation. And only then we can think about optimizing the network and reconfiguring the network. So this is how I basically engage and how we discuss with our service providers in Europe. The main feedback was, okay, but is there any OpEx saving by doing this, right? Can I actually save power? But more importantly, okay, you can touch my network, but please don't compromise my network, right? I don't want to lose any performance, and most importantly, I don't want to lose network resiliency. How can we assure that? By leveraging some capacity and simulation tooling. But there is kind of a switch of paradigm in the way you are using your network today and the way you want to build and design the network in the future. In one hand, we've been designing network to be available, reliable, stable, right? Your network is supposed to be resilient to your peak hour traffic, right? Even during the worst case scenario. Like even during the peak hour traffic that you have, even during the worst case time, you should be able to handle your customer SLAs. And you're building a network with the intent in mind to minimize your CapEx, to minimize your costs of your service for the bandwidth you give available to your customer. That's one-sided story. And on the other end, we try to get something more adaptive, something more optimized, something more efficient in your network. In a sense, we are trying to get to something that more that the software industry had kind of understood on. We scale the application up and down based on its utilization. we are on the paradigm of more on-demand resources, right? Where you can achieve more energy-efficient design. In that sense, we try to minimize the watt per gigabyte or the watt per capacity. Or if carbon footprint is the most important thing for you, at the end, the carbon footprint by a gigabyte. Obviously, this is not a one-sided story, right? This is not one or the other, right? There is a balance to achieve in between the two. And there are some trade-offs, right? But to take a decision on those trade-offs, we need a platform to decide that. And this is exactly what we have been working on. And the prototype I'm going to display today is called demand-based energy optimization. The concept is quite simple. On a classical service provider core network, we assume that you are able to automate your optical transport network and your IP over the network. You have an utilization that fluctuates throughout the day, right, or throughout the weeks, depending type of network you are operating. And the utilization on your network, from this utilization, you can already find some pattern of utilization. We can highlight some times of the day or times of the week that you have kind of a high utilization of your network. And so other times where the actual utilization of your network is quite low, quite low demand periods. Although you have a seasonality of the traffic, the actual power consumption of your infrastructure is actually not proportional to your utilization of your network. I mean, it does vary during the day, but not in the same proportion as utilization of the network. So then, the concept is, at the end, quite simple, is during this downtime, would it be possible to find some hardware, software, resources that could be put into sleep mode, shutdown, whatever means the box will support? In a sense, we will try to find and highlight components that could be shut down so we could deactivate over provision capacity during those low time periods. Obviously, you want to do this without losing any resiliency on your network, so you don't want to lose any node adjacencies, right? And for that, you can start focusing on parallel links or link aggregations, right? Once we have this, we can answer, a question that I have a sub-question in it is, does it really worth it? Can we achieve actually some saving with this? And to answer the question, to fully answer the question, we need to decide on the duration of such optimization, right? And only then we can think about automation and then how do we schedule going from the high demand topology to the low demand topology. So what is great about service provider network is that you realize that is purely human-centric at the end. Your utilization of your network is following the utilization, it's kind of a shifted utilization, but the shifted utilization of the actual user. It tends to be more utilized during the day and a bit less during the night. It's a bit shifted, right? You're going back at home, you're watching Netflix, utilization is going a bit higher, and then it goes down. Which is actually quite a good thing, if you think about it. From previous conversation from Stephen Parse, we had the thing like during the night, the carbon footprint is a bit worse than during the day. So because utilization is lower during the night, that would be quite interesting to lower the actual power consumption of the network. But then the big question is, where do you draw the line? What is mean low utilization of my network? A quite intuitive way of thinking is the lower the utilization percentage you set, the higher number of resources you could be put into shutdown mode or sleep mode, right? But for a lesser period of time. And then you have the granularity of the thing you want to achieve, right? Should you try to find the best solution for the hour, for the day, for the week? You do like one optimization a day, one optimization a week? So you have several things to take into consideration. So to achieve this, like to find utilization, we can leverage some open source tooling for statistic analysis and some machine learning type of algorithm to predict the traffic pattern. But what is more important to me is like to test the feasibility of this. It doesn't mean that because you have only 10% of utilization overall on your network that you can shut down links, right? Because you might breaking some SLAs for your customer if you do that. So to answer those questions, at Cisco, we are using WAE, WAN Automation Engine, to do some analysis and simulation on the platform. Just like this, like either are you familiar with WAE? Are you already using WAE? Just like wave your hands. Okay, say like about 5 to 10% of the audience. So briefly, what does WAE do? It's quite simple. WAE does build an abstracted network model that includes the topology and the traffic. So if available, you have the optical topology and then your IGP topology that is retrieved from the network. We get on top the traffic demands. What the traffic in demands is a directional amount of traffic you have between every set of pair of nodes in your network. And we compile that into what we call a network model or plan file. And with that plan file, you can then run some simulation scripting, right? So something like, what is my worst case failure? What would be my plan growth if my traffic is growing? Or doing some optimization of metrics. And yeah, before you ask, you can interact with the graphical UI of WAE, but there is a native Python SDK that lets you interact with the network model. That way you can implement your own algorithm, or even more, you can augment the existing model, adding your own data that is relevant to your use case. So, before I run into the demo of such integration, let me guide you through what you are going to see in a short while. So I'm going to start on WAE, WAN Automation Engine, so the offline planning tool. I will have a high demand topology. When I say high demand, it means my capacity is at full level, but my actual utilization of my network is quite low, right? I have the full demand, so I know all the traffic going on my network. And using the WAE add-on, the prototype WAE add-on power optimizer, I would like to try to find an alternative topology that has still the same shape, right? So we don't want to modify the IGP shape, but with less capacity. So overall, we want to increase the actual utilization of your network by lowering its capacity. It will be kind of a top of the iceberg type of demonstration. We want to interact with human being here. But the real intent behind is kind of to have like more machine-to-machine type of integration. At the end, I want an API that will be able to give me some information about my network. So today, the output data will be maybe the total interfaces that we will be able to put in sleep mode, maybe some specific software component that could be shut down during your optimization. But you need as well some figures, like the actual energy saving that you could achieve by doing this, right? So comparing the values between the previous topology and the new topology. And you want the list of interfaces, ports, and whatever that you could shut down. And this will become the intent payload that we could give to NSO to actually automate from the first topology to the new topology. So I am going to run into a demo. I bring with me my best friend, my laptop. This is a recorded demo, but let's make it interactive. I have loaded here a dummy topology. This is not an actual service provider network. So we are on WAE design, so it's an offline tool, right? I'm watching the topology, and we are on the weather map type of view, right? So the coloring of the interface is equivalent to the actual utilization of the said interfaces. For instance, here, if we take, for example, the link between Paris to Bordeaux, there is about 25% utilization in my Paris to Bordeaux, and about 33% utilization between Bordeaux and Paris. This is a fully correlated model. So if you select an object on the layer 3 view, you could see where on the layer 1 topology where the actual optical transport is carrying my demand. The model of WAE, I'm not displaying every single table here, is represented by tables here, but I have, for example, the interface table, the circuits, the demands, some traffic engineering information like the LSPs or segment routing policies that you could have. And if it's available to WAE, some layer 1 information as well, like the nodes, the circuits, and the port that you have active in your network. because it's a fully, once again, correlated network, if you select an object, you can filter it down to its sub-elements, right? So, for instance, my bundle, my 300 gig bundle that I have between Paris and Bordeaux, I can filter to its sub-ports, right? So I will filter down to the ports. So on that bundle, I have 3 active interfaces of 100. They have some proprietary argument that belongs to the tooling. They are all active. But if I double-click on one of the interface, I have some basic information. But on the user tab, I can find some user-defined properties. If you're familiar with NSO development, at the end, it would be kind of an augmentation of the model that we have. Like, so adding more data to the modelization of the network model. Here we modelize 3 information. One is the power utilization of the interface, right, set to 100 watt here. We modelize as well the idle power of the interface. This is one of the key takeaways from morning presentation from Bertrand, saying like, although you are shutting down ports, you are still consuming power, right? So this is one way of modelizing things. And last but not least, we have, this is specific to the RSR9K, but we have the positioning in terms of slice for the interface. It will become relevant when the algorithm will try to find which interface it should shut down. It will try to prioritize interface that maximize the number of slices I would be able to shut down on the overall topology. Okay, so that's the type of information that I have access to. Now, with that network model, I can already interact with it with the native tooling from WAE. WAE comes with a set of capabilities we can leverage. We can go through the simulation engine. It has some capacity planning optimization or IGP metric optimization, or do some simulation like what is my worst case failure for a given traffic pattern. But leveraging the native Python SDK, you can implement, and the add-on feature, you can implement your own logic, your own algorithm. And this is what we've done here. We have a Power Optimizer tab. Inside the Power Optimizer tab, we have 2 main add-ons. One is called Analysis, and the second one is Deployer. The first one will be the one we are going to use to try to optimize my topology from its existing state to a newer state with less power consumption. And the second one is related to the deployment, so meaning the actual automation using NSO. So let's use the Analyze Power. I'm prompt with the parameter for the tool. I don't want to lose any adjacencies, so the minimal circuit count between each node should be at least 1. I want to have the maximum utilization in between 2 nodes to be maximum 75%, even after optimization, even in a worst case failure. In my case, I would like to optimize my lag members, but we could optimize as well parallel links. And because we are SR9K devices, I'd like to prioritize same slice interfaces. And from this time slot, we are going to try to optimize the duration on the 600 minutes a day. So let's press OK. And after a short while, the add-on will propose you a new version of the offline topology. So it's going to create a new topology. In this new topology, you will realize that you're running hotter, right? Your weather map is getting hotter, like you have more utilization of your topology. That makes kind of sense because we just reduced the capacity of the topology. We can find the actual port that have been shut down, but for instance, in my bundle between Paris to Bordeaux, now I'm up to 37% utilization. And it makes kind of sense because we can see on the bottom side, like one of the interfaces has been shut down, right? So now I only have 2 interfaces active in my bundle. One is now active false. We could try to find that for every single bundle in the network, but the add-on also as well produce a report. So I'm going to open the report section of the add-on. That will give me the lists of summary and the list of interfaces that have been modified. So this is kind of a web 1.0 type of visualization, but once again, the idea is more having something machine-to-machine type of integration. It's like just for human being decision-making, right? So some key takeaway, stay with me. It's a simulation topology. It will vary depending your network. But here we can see that we have a 35% optimization between the two topologies. The actual optimization over a day is down to 15% because we cannot optimize for the full day, right? Only 600 minutes a day. And then we have some figures for decision-making applications, like what's kilowatt per hour or megawatt per hour a year you could think about optimizing by shutting down some ports. Then we have some details on the number of active interface and inactive interface. But if we would like to automate that, we need some proper object we can act on. So the tool is proposing you the list of optimized circuits or optimized interfaces that are being touched, or we should be automating, and is proposing you as well the list of slice, in the case of ISRNK, that could be put into sleep mode in the case of optimization. Keep in mind, we are still in the realm of offline analysis, right? So if you disagree with the findings, or if you have more SLA you want to implement, you are free to run the tool again, change the parameters, try to specify some region that you don't want to never optimize because you want to keep that like this, because it's the way you operate your network. That's totally fine. You can play with that until you get to a point where you agree with the said optimization. And on today's add-on, we propose the deployer add-on that lets you activate, so push the topology to NSO. We support NSO or CNC. We specify a power state, so we want to put the slice in power saving mode. And we can press OK and push that to NSO. I will open up the NSO web UI. And as part of the, let's say, power-saving function pack that we are developing, there is one module that's called ISR9K Power Saving, which has two services inside. Like one is to put the interface into, to schedule the interface to power down mode, and one around APM, so ISR9K power management, the advanced power management, to shut down some slice. So inside my ISR9K power saving, I would get my services. One is the list for every single devices that has been touched, the list of interfaces that has been scheduled to be put into shutdown mode. And on the APM side, so the slice management system, the list of slice and the states that we want to achieve. Okay, to conclude today's demonstration and the things I wanted to discuss with you today, I'm conscious that today I showed you how to optimize brownfield, right? How to optimize what you're doing today. But for sure, the real intent we have behind is how we can better design what you're doing in the future. What you could achieve in a greenfield scenario where you could redesign your network from scratch, right? And how can you achieve this by having some more energy efficient network design? If we want to get there, we need the software to have, our hardware platform and the software to have more feature that brings energy proportionality, right? When the utilization of your box will rely on its actual power consumption. And only then we can think about having some interesting use case like carbon traffic engineering, right? So you're doing traffic engineering based on your carbon impact. Overall, on this journey, there is one key takeaway that I got with the different customers I've been working with, is that you realize that your power saving, until we get there, is directly proportional to your capacity to automate your network, granularity. If you are able to achieve fine granular automation, like if you're able to automate your network every hour, every day, every week, right? So in a more granular fashion, you will get some better savings. And what helps you bringing the automation of IP and optical layer is by leveraging some converged architecture, for example, for routed optical networking, for instance. Thanks a lot for having me. I wish you all a really pleasant event, and I'm not moving anywhere until I get some questions.
So no escape for you yet. You actually hit the mother load of questions. So
happy to answer.
I think you're talking about something, you got people's interest. So I'll just kind of work through these. So first question, are there real-world examples of successful implementation of what you talked about today in terms of leading to meaningful cost savings?
Yep. So we are working with several service providers. So they are using the live. Today it was a dummy information. They are not automating the network with it yet, but they are using it to plan. For planning, yes. For re-optimizing today, no. Okay. So the short answer is planning, yes. Yeah.
But your first two questions were, is it feasible and is it worthwhile doing?
Yes.
I think you answered yes to both of those at the end of the day. Okay. Second question, what's the difference between WAE as a product and CNC yesterday?
That's a good question. WAE, WAN Automation Engine, will be part of the CNC, capacity planning tool will be called in Crosswork, right? So here I was showing the offline tooling, but then you can expect it to be in line with the CNC architecture.
Yep. Yep. So they're complementary. I mean,
Today they're complementary. Tomorrow they will be, let's say, part of the Crosswork. Yeah.
Okay. Let's see. Will you consider collecting, implementing business as usual customer plans on SD-WAN on any other Cisco controller for power optimization?
So today was more on the core network, but like one key thing we are working on is to bring some APIs to those SDN controllers, saying like today what WAE can bring to you if you have like SD-WAN type of overlay is some metric of information, like if you were to deploy a new SD-WAN or if you were to accept more traffic right in your network, what would be the impact right of it, right? So I'm more looking towards bringing API to those controllers and a bit less to optimize it, but that's the way we are approaching the things today.
Okay. And if that didn't answer the question, chase us down later.
Yeah.
And if we touched on this a little earlier, is hardware typically meant to be cycled like we talk about in implementing these plans of turning, links up and down? Do we feel that hardware is actually designed to do that?
Yeah, I think it's so we are going back to the MTBF question, right? So. Yep. Actually, there is two things, right? My last point was on routed optical networking, for instance. And actually, it's the reverse way around. If you don't shut down your interface when it's not used, you are losing MTBF actually on the routed optical side, right? But that's quite true. I can rely on some of the infrastructure. I was more thinking of the line card level, for instance. Shutting down your line card, you need to be really confident about this, right? And I'm more looking towards software features native, like putting the slice in shutdown mode or like having sleep mode for interfaces and not full shutdown. Yeah.
Okay, cool. Then last question, how do you optimize lag links?
How do I optimize lag links?
Yeah.
By shutting down some port numbers.
Okay.
Yeah. Or yeah, if it's more details on the question.
Okay, simple. So we have a couple more questions, but we're out of time here, so we will answer them offline, or you can come find us.
I'm here during the tonight, like roundtable, so I will be there to answer the question if needed.
Okay, cool. Thank you.
Thanks a lot for having me.